logarithms to get the exponential stuff to go away because these don't have the same base. And they can't really be rewritten to have the same base because there are no common factors between 25 and 21, which are what this isn't 20, it's 10 and 21, which would be, oh, that doesn't even work. There are no common factors between 2 and 7. Okay, so that doesn't work. So basically, it doesn't matter what base you choose. You just want to choose a logarithm to get the exponential function to go away. So I'm going to do log base 10 on both sides. You could do log base e. It doesn't matter. 5, 2x log 3, 7x. Okay. And now I can split this up because I have a product of two things inside of a logarithm. I can rewrite it as the sum of two different logarithms. So log of 5 plus log of 2 to the x equals log of 3 plus log of 7 to the x. Okay? And then, because I have a logarithm of an exponential function, I can pull that x out front. So I'm just going to rewrite everything. Log 5 plus x log of 2 log of 3 plus x log of 7. Okay, so that's that. Then I can combine sort of combine like terms. So I want to get the stuff with the x's on the left, the stuff with just the numbers on the right. So I'll have x log of 2 minus x log of 7 and log of 3 minus log of 5 on the right. And then what we can do here is we can factor out the x on the left-hand side. So many parentheses. And then I'm just going to go ahead. I feel like we could rewrite this in a little bit nicer of a way. Let me double check the property. So the difference of two logarithms is the quotient of them. So I am going to do this. When I have log of 3 minus log of 5 and they have the same base logarithm, I can rewrite this as log of 3/5. And that's just, it's much nicer to have one term with just one logarithm. So I'm going to do that. And then on this side, I should have rewritten it already, but I'm going to divide by what I would have rewritten it as. I hope this isn't too confusing. Log of 2 over 7. Okay, that's the same thing as the difference of those two logs. Okay, so this cancels out here because they're the same. The difference of log of 2 and log of 7 is the same as log of 2 over 7. So then I get that x is equal to log of 3/5 over log of 2/7. I'm just like second guessing myself all the time. I'm trying to make sure that I'm doing it right. Yeah, that's right. That is right. Oh, and now we could simplify again. Does this say that it's not telling us to simplify a ton, but so there's this other property right here, log base a of x. So when I have both of the same base here, and the base here is b, I can rewrite the logarithm with a new base, which was the thing inside of the denominator. So I could have log base 2/7 of 3/5. And then I rewrote it as one logarithm. A lot of the times, IB will ask you to do that. It'll ask you to rewrite or solve and then rewrite in terms of a single logarithm. That will come up a ton. So there's that example. I guess Hold on, let me see how much more there is. I want you guys to practice this one on your own. I'm going to have this one be a you do. But obviously I'll post a solution for you. So go ahead and try that one on your own. Hopefully it won't be bad. I think it's actually a little bit easier than the other one, personally. Okay, so let's flip over to the back. Sometimes there will be a hidden quadratic within the exponential function, which is super fun. So let's go ahead and do this. So I'm going to just rewrite this so that I have, obviously I'm trying to make this a quadratic, so I want to pull this 2 out as an extra power. So I'm going to have 2 to the x squared minus 2 to the x minus 6 equals 0. I'm moving the 6 over to the other side as well. Okay, now I'm going to rewrite this so that 2 to the x is just one variable, so it's easier to see how this looks like a quadratic. So I'm going to make y equal to 2 to the x. So then I have y squared minus y minus 6 equals 0. So now it's very clear that I have a quadratic function here. I can rewrite this by factoring y minus 3, y plus 2 works. Okay. And so then I get y equals 3 and y equals -2 as my two solutions. And so then because y was 2 to the x, I have to rewrite this. 2 to the x equals -2. Okay, now here we need to ask ourselves, is there anything, any value of x, any exponent that will give us a negative value? The answer should be no. If you don't believe it, you can graph it on your calculator, like graph the function 2 to the x, and you'll see it's all in the first quadrant. It's all positive. So this one should have no solution. And then here, 2 to the x equals 3. So I'm going to take the log base 2 of both sides. And again, I picked the log base 2 because I have the base as 2. The base of my exponent is 2. So I'm going to have x equals log base 2 of 3. And that is my final answer. All right, the next one is a you do. So you guys try it, and I will post the solution. And I'm going to go ahead and do that with the practice below as well. I'm going to post the solutions, but I want you guys to go ahead and practice. I'm going to put a short cognitive thing with some exams assignment up. I'll post the link to it, but you should be able to access it through Cognity, and all of you should be on there. I will double check when I create it, and hopefully that'll give you some extra exam style practice for solving exponential equations. All right, well, I hope you guys have a great rest of your day. And yep, it's the last week. We can make it. And hopefully, I'm praying that we get to be back in school next year for the fall. I'm pretending like we're not going to be, because that would be disappointing. So if I keep that disappointment in my mind, then my hopes won't be let down. So that's what I'm doing. But I still hope that we get to be together in the fall. All right. I'll see you guys later.